Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Today we're working on our Workslate again. You might remember that in the first part of this series we did some mechanical repair to the cassette mechanism by machining a screw to fit and replace a nub on the bottom of the pinch roller arm. I'll link into the first part right up here. Today we're going to look at replacing all the electrolytic capacitors on the board and identifying an inductor that actually fell off the board. For some types of computers, like Commodore 64s and Amigas, there are already capacitor lists out there for you. Or for some types of computers, the manufacturer was nice enough to put a parts list in the back of the service manual, which makes it a lot easier. For something like this, there's no such list. So the procedure of going through and specifying all the components and figuring out what to order is a little more time consuming. So let's go through that process to see how to find the parts that you need. I start the process by laying out the circuit board and taking some high resolution photographs of it. This was actually done by taking 4 to 6 photographs and stitching them together with some free stitching software. If I had a higher resolution still camera, I wouldn't need to do that. Once I have the photograph printed out, I'll circle each capacitor and write its part designation beside it. Then I'll make up a spreadsheet like this, which lists all the components, grouped by type, and I'll assign a color code. The color code is used on the capacitor map itself. For each item in the spreadsheet, I'll list the capacitance, the working voltage, and the dimensions of the capacitor body. For taking the measurements, I use dial calipers. This is an inexpensive set that cost me about $12 several years ago. I want to shy away from the ones that are made out of plastic. Those aren't any good at all, and just try to get a decent quality set in your price range. These calipers are calibrated in thousandths of an inch, but you can also get them calibrated in millimeters, whatever works for you. I'll take my first set of measurements with all the capacitors on the board and record those. This just helps categorize the capacitors by not only the capacitance and working voltage, but also the physical dimensions. I'll transfer the dimensions over to a separate column, which makes it easier to read, and then convert my measurements, which are taken in inches, into metric, because that's what you're going to find on most capacitor data sheets. With this information, I can then go look up on, say, Mauser's website and get a general idea of what capacitors might work for each of these locations. Then I'll write that information down under this column. Here I'm using Nichicon capacitors. Now that I have an idea of which capacitors are the same across the board, I can pull one of each type to get a little closer measurement of the hole spacing on the board and the capacitor body. You might find that the hole spacing on the board is slightly larger than the lead spacing on the capacitor, and a lot of times that just has to do with how the capacitor is on the tape for the insertion machine. By measuring the hole spacing and the pitch of the leads on the capacitor, it gives you an idea of what parts you might be able to get that will work. I penciled in a letter designation beside the color code, and in the final version of this spreadsheet, I've added it here to where the color codes are. This just helps identify the capacitors when we order them. And there's a table down at the bottom that shows the quantity of each capacitor, and there's a link. You can download this document as a PDF below in the description. This is one of the capacitors I pulled off the board, but the leads fell off. You can just see that it said 22 microfarads, 25 volts. There's the manufacturer's mark, and there it says 85 degrees C. The next step is to take the high-resolution image that we took earlier and place a colored circle beside each capacitor or group of same capacitors that corresponds to the color code on the spreadsheet, and insert the capacitor designation. This gives us a nice color-coded map where we can find not only which capacitors are similar, but where all those are on our spreadsheet. You may remember from the first video there was an inductor that was missing on the board. This copper and these ferrite core pieces are from that inductor. I actually went to the other Workslate that the owner sent me and found the part was on there. It was damaged, but it hadn't quite fallen off yet. Well, my first thought was that maybe I could measure the inductance, and I took the part under a high-power microscope at work and managed to get the leads out enough to hook a meter to, but before I could connect a meter to it to measure the inductance, the leads broke. So my next brilliant idea was to try to unwind the copper from the coil so I could measure the length. It was impossible to unwind the wire from the coil body, and I wound up breaking the coil body in the process. This is what it looked like. It was kind of a T-shaped with a larger base. The wire was wrapped around the center part here, and one end of the coil wrapped under the base that way, and the other end of the coil wrapped under the base that way. They had affixed some pads to the bottom of the ferrite that the leads were wrapped around, and the whole thing is soldered to the circuit board. So at this point, I wasn't quite sure what I was going to do to determine what value this coil was. And then it happened to occur to me, after looking at the circuit board again, that there were several of what looked like to be the same inductor all over the board. I had been so fixated on the one broken / missing one before that I ignored this fact. So I took my cheap little meter and I measured several of these, and they all measured the same inductance. I was pretty sure they had used the same part all over the board. So I removed one of these other coils off the board and I measured it with my cheap little component tester, and it read about 530 microhenries. Then I took the part to work and I measured it on a good quality tester, and it measured about 450 microhenries. So knowing the inductance now, I measured the size of the base of the part. On surface mount parts, the size of the base is one of the primary designations of the part type. For example, a common size of the larger surface mount parts is a 1206, which means that it's 120 thousandths that direction and 60 thousandths that direction, which is about 3 millimeters by 1.5 millimeters. There's also a metric designation, which would be like 3216, which means 3.2 millimeters by 1.6 millimeters. This inductor in question was a little larger. It was an 1812, which is 180 thousandths by 120 thousandths. So now we know the footprint size, we know the inductance value, and we know the profile of the coil, so we have a good, physical description and electrical description of the part. Now we just need to find what manufacturer made that particular part or a suitable replacement. So at this point we know the inductance value, we know the footprint size, we know that it has a ferrite core, and that it's wire wound. So I did some searching online using those characteristics and found several matches from prominent companies like Murata and Coilcraft, etc. But by using the pictures that the search returned, I was able to determine that this was most likely a Murata part. So I went to Murata's website and, using their search tool, narrowed down the choices based on the package size, that's the footprint, and the inductance value, and I was able to find an exact replacement part, which were only about 50 cents a piece from Mauser. Got everything set out here to get started recapping this thing. Got some solder, flux, solder braid, got the rework station warmed up, and even have a new set of these fancy scratch pins. Saw these on Gadget UK's channel, and I'll link his channel in right here. This one has steel wire, brass wire, fiberglass wire, and nylon. It's used for helping clean up the damage traces, that type of thing. Thought I'd give that a shot. Some alcohol, a brush, Q-tips, little screwdriver, that type of thing. Now, normally I would do this one capacitor size at a time. It's easier. You don't get them mixed up. Since there is some leakage damage on this board, I think I'll take it one section at a time so I can remove, 3 or 4, 5 caps, clean that area up, and then put the new caps on. Let's get started. I'm going to be starting in this area of the board, and I looked at my color-coded capacitor map and see that these 4 capacitors here are types A and E and C. So I've set these out. It's the advantage of marking your packages ahead of time. And so we'll start removing these now. I was just making a note on a piece of paper that this bodged-in capacitor here, which I called C92B, has its negative lead attached to pin 4 of U48, which this IC is upside down from our standpoint. This is pin 1, 2, 3, 4. The negative goes to pin 4 here, and the positive goes to this trace that's just above where that capacitor is. Okay. So this isn't too corroded here on this particular part. But I'm going to go ahead and add a little flux to those areas that we're working on. Got the desoldering tool here. The trick when desoldering is to let the joint heat up long enough that you're melting the solder all the way through the board. You don't want to stab at it really quick. You don't want to put a lot of pressure down or wiggle it really violently. Just nice and gentle. I'll put the iron down on there and give it maybe 2-3 seconds and then try wiggling, and once I feel it that it's wiggling around really easy, then I'll suck the solder off of there and I'll keep the pump running for at least a couple seconds. That way you're getting the solder all the way through into the collection chamber and not stopping with a big blob of it in your tip. I'm not really putting any pressure down. I'm just kind of going side to side. This one that just fell right out. This one is loose. I'm going to go ahead and get this one from the top that's kind of straddled across there. Get it out of the way. Go ahead and put a little dab of solder on the tip of the iron. That'll let the heat transfer a lot better to this pin. There we go. That was easy. I know my fingers are kind of blocking the shot there. Okay, now I'm going to use some small pliers. Okay, gonna do that again. Oh wait, that capacitor is tacked to a V. It makes it hard to get to. There we go. That extra little blob of solder on the tip of the soldering iron just helps with the heat transfer. I'm going to set that capacitor aside in the orientation it was in on the board, which will help me later remember it. I'm going to wiggle the pins on this big capacitor here. There we go. I've got this little bitty guy who's still kind of stuck. And on this one, when the insertion machine puts these parts in, it kind of cuts the leads and crimps them over to keep the part from popping out as it goes down the line. And that can mean that the lead will stick a little bit to the side of the hole. A little more solder. There we go. So, and I'm just pushing the lead slightly and very carefully to straighten the lead up, and then I'll desolder it again. Sometimes you can do that directly with your desoldering tool if you catch it the first time, and sometimes it takes a little extra effort. Okay, now we've got those parts out of there too. So now I'm going to go ahead and clean up this section of the board, and then we'll put the new caps in. Well, this area really didn't have a lot of leakage. It's in pretty good shape, so it won't take a lot of effort to clean up. Just got a Q-tip with some alcohol on it. Now this one here, C91, looks like there might have been a little leakage. The pads are kind of dull. I see a little dark colored spot under the solder mask, so that deserves a little more attention. So I'll start out with my screwdriver, or you can use a small knife for this. I think just very gently scraping that solder mask back from where it looked damaged. I'm going to give that a peek using the lighted magnifier here. Yeah, it just looks right around the solder pads there, where it's discolored. It looks okay on the back of the board. So now I think we'll try Gadget UK suggestion and use this little fiberglass scratching pin just to polish those up a little bit. Oh yeah, that did a fine job. Look at that again under the magnifier. Then I'll coat this with solder. Using some solder to plate the bare copper that we just exposed. I'll flip the board over and we'll clean up the back here. One other thing I need to try to do is clean up this via where that bodged on capacitor was. And I might note that I'm using a different Q-tip for cleaning up any goo from the capacitor as I am cleaning up the flux residue. Right there is where that capacitor was bodged on. There we go, we got our via all cleaned out. Okay, so I think I'll replace C46 to start with, which is circled red. That's an A, which is a 1 microfarad 50 volt, which is this package. Okay, we've got our new cap with its requisite early long leads. And it's a bit odd on this board that they mark the positive side of the cap rather than the negative side. But we have electrolytic caps. Normally they mark the negative side because the negative side is marked on the cap itself. If these were tantalum caps, the tantalum caps have the positive side of the cap marked. And why that's different, I can't tell you. These two large caps are the letter E's, which is orange. Again, they mark the positive here, which means the negative is down toward this end. Just been in these relatively close, been in the caps relatively close to the body because that's how they had it previously. And if you're in doubt, you can always take your package of capacitors and hold one up that you haven't put in there. Yes, these also are indented on the positive side of the can. I'll just bent the lead slightly out to help hold it in place, and I'm going to tack two ends, and I'll push up on the capacitor from the bottom to make sure it's kind of in there nice and square. Do the same thing there. This one needs a little more solder, but I'll wait till I do the other end. Same thing when you're soldering, you need to keep the iron on there long enough to heat the joint up all the way through. Especially like here, where you can see it there. This has a big ground trace right here on both sides, so it's going to be a little more difficult to heat up. So put a little solder on the iron, hold it to the joint, let it heat up, and then add a little more solder. This one I'm kind of watching how it's heating up that big fat trace right there. This one needed a little more solder. Okay, there's 3 of them. I'll come back and clean up the flux after I'm done soldering everywhere. That way I can get the whole bottom of the board at one time. And it'll be the same idea with the rest of the board. Only some of these areas are going to have more cleanups. When we get to one of those areas, we'll do some more filming. I almost forgot this little bodged on cap here. I took the original one and the replacement and I held them up together. I bent the leads so the new one matched the old one. I just tacked it right into the same place. No biggie. Well, we got this area done and then started in on this area, which was the worst of all. Remember, we had an inductor that was missing. That was located right here originally. When cleaning this up, I also had a resistor pop off of here. And luckily, there was just enough pads left on it. I was able to take a resistance measurement, and it was actually marked 101 on the back of the resistor, which would indicate it was 100 ohms, and I measured it. It was 100 ohms. It's a 1206 size resistor. I have one of those, so we'll put that on there. This area took a lot of scraping and fluxing and resoldering and desoldering to get all the nastiness off of here, especially where the 2 parts fell off the board. Yep. I was worried that the electrolyte from the capacitors that caused all this corrosion might have gotten under some of these other parts. So as I understand, it is a base. It's caustic. So I went and looking in the kitchen to see if I had any mild acid like vinegar, and what I found was lemon juice. So I put some lemon juice on this area and I've let it set about 20 minutes. And now I'll wash this down with alcohol and then tin everything in here. And then we'll start putting parts back on. Okay, I've got a rag under this corner. When you're trying to clean up an area like this, you just can't smear it around with a brush. You can go with a Q-tip, which will also absorb some of the stuff. But I'm trying to flush out anything that might be trapped in the nooks and crannies here. So I'm very gently scrubbing with the toothbrush with the board at an angle. So the alcohol will run off the board and take with it any of the nasty stuff. Go ahead and get the back of the board in that area too. The back really wasn't bothered like the front was. I'm just going to go lightly over those areas where the parts were with a fiberglass pin. Okay. Here is our board. I'm going to add some flux to all these bare spots. Now we'll tin everything with some solder. Now we'll suck all the extra out of the holes. Now there's a few components right in here where this capacitor had leaked and the resistor fell off. Clean off the flux residue from what we just did. Okay, these few components that are around right here where that capacitor had leaked. Put a little flux on those pins and just touch them up, just to be safe. Imagine I'm completely blocking your shot. A little more cleanup here. There was a slight amount of pad damage right here where the inductor was, but it's still intact and the traces are connected, so it will work. Okay, the first things we're going to replace here are the surface mount parts, and we'll start with this 100 ohm resistor. Put just a little solder on my iron. Use my screwdriver to hold the part in place. Add some extra flux. A little more solder on the tip of my iron. Okay, time for some capacitors. You know the drill here. Oh, I forgot about our little inductor friend up there. I'm going to go ahead and apply the flux first this time. This other one is the one that I pulled off to measure the inductance. So I'm just going to solder both of these on at the same time and have the surface mount stuff taken care of. Now, these inductors are not polarized. There's no positive or negative. We just want to get them kind of centered on the pads there. That pad there was not wanting to take any solder, which, is problematic when you're trying to solder. Okay, now we're getting a little solder action sticking on there. Okay, surface mount parts out of the way. Now the rest of this is just through-hole parts that we've seen before. Just double check your position one at a time. Make sure you're putting the negative end and the positive end in the correct place. Here we've got the board recapped. It was a lot of work, hours and hours of cleaning and scraping off the gunk that leaked from the capacitors, and more cleaning and more scraping and more fluxing and more soldering and desoldering. But it all worked out okay. There was no, really bad permanent damage, just a lot of cleaning. And I got the cassette mechanism put back in, and I tried to do a quick test, and it didn't want to pull the pinch roller back. And I hooked up an external power supply here and found out that it took at least 3 volts to get this thing moving. And I tried on the second Workslate that the owner sent me, and it only takes about 1.5 volts. And you see this big IC down here? This is U29. Looking at the draft service manual that's available, found out which signals from the cassette go into U29. This is some sort of gate array that controls the cassette operation. I found out that which pins control the fast forward and rewind and play and things like that, and which control this motor. So I was able to measure here on pin 61 and 62. Pin 61, which is right up in this corner, tells it to drive this motor, and when it sees the switch here be made, it turns that off and it turns on pin 62, which turns on another set of transistors that act as a brake. So I measured the signal right at the motor, And notice that when I turned the unit off, the current jumped up to about half an amp, whereas it was about 125 milliamps in normal operation. And I measured the voltage across the two terminals for this head motor, and lo and behold, it was being powered then. So as the unit was shutting off, it was trying to pull the head and pinch roller back as part of the shutdown procedure, but it couldn't move. This was being bogged down. So my guess is that there's a current limiting resistor in this path that drops voltage if this thing should happen to be drawing too much current because it's overloaded. So that either means we've got a bad motor here, or there's some other mechanical issue I didn't see when it was apart before, which is sad because that means I've got to pull this out again. Now, as I said, I checked the second Workslate, and the head motor worked fine in that, and I also found another problem with the piece back here that was bent out of place, and I broke it trying to bend it back into place. So I think what I'm going to do at this point is pull the cassette unit out of the other Workslate, clean it, change the drive belt, and swap it into this one and see if that doesn't get it working. One other oddity I found is that the board revisions between these two are ever so slightly different. There's a few minor changes. The capacitors are all the same. The major chips are the same. There's some small component changes, some little capacitors and resistors and stuff like that. Okay, I pulled the cassette mechanism out, and here is the head motor. You won't be able to tell from that far away, but you might recall in the first episode I mentioned something about there being some slight tooth damage on this cam gear, but it still seemed to work. Well, when it gets around to where that tooth damage is here, it catches, and that's what binds it up. If you have enough voltage applied, it'll power through there, but of course the machine's not designed to run like that. So I've got the power supply set to 1.5 volts now, and I've tried to clean up the teeth a little bit, and it sort of works now, but you can see it catching. So this would probably work for a little while in the machine, but it's not great. My guess is it'll fail within a few months. So I'll go ahead and get the second cassette mechanism pulled out and cleaned and replace the belt and swap into the board that I've recapped, and hopefully we'll have one working unit. It's very tough to tell. There you can just quite see, or there you can just sort of see right at the tip of the screwdriver is where the tooth damage is. That's what's causing our problem. Okay, I swapped in the second cassette mechanism after cleaning it and replacing the belt, and it is better, it runs, and everything seems to move, but everything is still not 100% perfect. Let's take a closer look at that. I might mention that I took the LCD out and set it over on a rag here to keep from stressing the cable too much, and just have the keyboard cable stretched out like this so I can rotate this around to punch the keys, and it is just enough flex there that it works. Okay, sorry for the glare on the screen right there from the overhead lights, but it is what it is. Okay, I have a microcassette in here, and if I try to close it, it's not going to close because the head is still sticking out a little too far, as is the pinch roller. And I'll zoom in here in a bit, and you'll see that there's still a little travel left on this mechanism. And both this mechanism and the one I repaired have the same issue with travel, which I think was a problem that was building up over time based on some damage to the cassettes that I saw. We'll go into that in a little bit. But what I'm going to do here to show you what happens is I'll pull this mechanism the rest of the way down and close the cassette, and you might just be able to see that the cassette is moving. And it says on the LCD that it's searching for data. What it's doing right now is rewinding, and it's keeping the head back for this. It'll rewind through the whole tape and stop and then start playing it forward after it moves the head out. So now it's going to automatically stop when it reaches the end. It ran the mechanism in, and now it's trying to see if there's any header information on the tape to let it know what sort of tape it is and if there's any data on it. And it doesn't seem to find anything, so it just backs the head off. And if I try to eject it at this point, it won't come up. And I have to move this out about another 2 millimeters, and then it'll come up. So other than it not wanting to bring this head and pinch roller mechanism all the way out, everything seems to work. There is one small problem on the back of this board I need to fix, where one of the bodge wires came loose and it damaged a small capacitor in the process, so I need to replace that. But I think this works except for this coming back all the way. I need to find a tape that I know has some data on it to see if it'll find the data. Okay, the LCD says checking for data. It's doing the same thing where it's rewinding through the tape. Now this tape is one of the training tapes that comes with the unit, so it should have some data on it. So I'm hoping it will find it and give us a different message on the LCD. One other thing I noticed on this particular cassette mechanism is that the screws for the head alignment were loose and the head was a little cockeyed, and I tried to straighten it up, but right now it's kind of a by gosh, by golly adjustment. It looks right, but I'll have to see if it actually reads the data. Okay, we're at the end of the tape, and it's popping the head up there, and it's playing forward, and I'm not sure what that means. This arm here, which I've removed the spring from, slides across and pushes a little switch out that touches the tape for the right protect notch, and as this flips up, it's supposed to hit a little ramp shaped piece that sticks out this way and push this arm back, which pushes the switch back. That was all mangled up, and in the process of trying to fix it, I broke it, and then I later realized that there's a small E-clip on the bottom of this shaft, and you can pop all that off of there. The other thing that's goofed up on this original cassette mechanism, this is the one I machined the part for, is this. This is the switch that senses when there is a cassette in there. You can see it's just kind of arc-shaped. It's supposed to have a piece that goes down. And when the cassette goes in there, it pushes this piece against this piece and completes a circuit. But part of that is missing. So the right protect tab thing we could not use. We just wouldn't be able to right protect the tape. The cassette in there sensor is more important, so I don't know what to do right now about that. Looking through several of these tapes that the owner sent, I noticed these little notches right here. In some places it's not as bad, like here. Other places it's worse. This is where the tape was contacting the read-write head, because that pinch roller and read-write head arm wasn't going back far enough. So it kind of makes me suspicious that this, whatever went wrong mechanically there, was getting worse over time. And that's what caused this damage. So this is where we are. We've got the board recapped, and that went fairly well. We swapped in the second cassette mechanism, And mostly mechanically that works, except for the pinch roller arm. They're not going out quite far enough. And I'll look into that later if I can figure out the rest of it. The problem is it's not reading any data off the tape at all. It doesn't think there's anything there. And I was trying to measure the signal here and looking at the service manual, and I first thought, oh, there's no power on the amplifier chips there, on those op amps. And I got to reading the service manual some more in the power supply section, and this unit's smart enough that when it's not using the cassette mechanism, it shuts off power to all the amplifier circuits to save battery life. So I measured the output pin on this U29, which is the gate array that controls the cassette mechanism, and there was an output saying to turn the power on when it was running the tape. And then I measured the power on the amplifier IC, and it was there when it was actually running the tape. So that was okay. But I was reading nothing coming from the tape head itself, which I think is kind of bizarre. I would think I would at least read something from it. So I'm not sure what to do about that. And I thought, well, maybe somehow all the tapes got erased. They got too close to a magnetic source. So I took one of the tapes, which is one of the training tapes, and I got out my dad's old micro cassette player, and so there's obviously something on the tape, but this unit's not reading it at all. And it kind of poses a problem for the owner, how to use it without being able to save or retrieve data. This does have a capability to connect this Workslate to another one over a data cable, and maybe that can be simulated with a PC on the other end. I'm not sure yet. I'm not ready to give up on the cassette mechanism completely. I don't understand what's going on, so I'm going to have to spend some more time researching what signal I should get directly off the magnetic read-write head from the cassette mechanism, and figure out a way to fix it so that pinch roller arm goes in and out like it should. It's curious that both cassette mechanisms are doing that same thing. The evidence from the tapes of those little nicks I showed you would indicate that it has a problem that's been getting worse over time, so something has worn out in there. It's just not evident from looking at the mechanism what has worn out. There's no shiny spots or spots that look misformed or worn. So I'm just not quite sure what to do yet. It did occur to me just recently that this cassette mechanism is probably out of a microcassette telephone answering system. Now, you remember the ones that only took one tape? You would record your outgoing message at the beginning of the tape, and then as calls were received, it would rewind and play your outgoing message, and then fast forward to get past the messages that were already there, and then it would record the message. So I'm thinking this is probably the mechanism out of a mid-80s, early 80s microcassette answering machine. So, there's a possibility that if I get lucky, I can find such an answering machine for next to nothing and get some replacement parts, or have one that's working to take measurements from a working system. Maybe that will help. I'm not quite sure. So this was kind of a letdown, really. We did a lot of work. Got maybe 90% of the way to what seems like it's done, but the cassette's not working. The rest of this is working. The new capacitors are fine, so it's going to be fine for, tens of years yet, so the owner can use it, except can't really save or load anything at this point, which is kind of disappointing. Well, I'm sure there'll be a third episode once I figure out a little more on this, and stay tuned for some other content. Say, if you're a subscriber, thanks. I really appreciate it. If you're not already a subscriber, what are you waiting for? If you look down below, you'll see a rectangular subscribe button. Click on that little dude, and then you'll see a bell-shaped icon pop up. And if you click on that, it'll tell you just as soon as I post a new video. That way you can watch it right away. If you have questions or comments, or you know anything about these microcassette mechanisms, please leave a comment down below. I sure would appreciate it. Until next time, bye.